All right, guys, I'm ready when you are. Again, you can ask for a type of problem. You can ask for a specific problem. Just let me know what I'm looking at when you let me know what type of problem it is. For those of you just joining us, I am waiting to hear from you which problems you would like to go over. I brought home all of my answer keys to every homework assignment. So all of the worksheets I have available, and I also have available the quiz and the test review. So I'm just waiting for you guys to let me know what you need help with. You can also ask for a generic problem, like I need help with, there's an example, with cart problems. So you can tell me a generic type of problem, and I can also look up those types of problems and help you out with that. So card problem, do you guys need help with like what is in a deck of cards? Do you want me to go over that first, or do you want me to just like jump straight into the card problem? Okay, so just to clarify so that we all understand what's in a deck of cards, it would help if I pushed the pen. There are, oh, you're going to do that again, are you? Okay, hold on. 52 cards in a deck of cards. So that's like the total amount. Oh, it's being weird. There we go. Total amount is 52 cards. And then from there, the card is split into black cards and red cards. And there are, sorry guys, I'm on a different computer today, and the keyboard thingy is not being nice. Hold up. Let me see if I can fix that. Okay. So there are, nope, it does not want to do that motion. We'll try typing it instead. Uh, 26 black cards. Oh, I hope if I could spell it correctly. And 26 red cards. Okay. And then from there, the black cards get split again. And the red cards get split again, like half and half. It's always half and half. And then there are 13. Oh, I keep trying, and it does not want to work today. Okay. There are 13 clubs and 13 spades, and those are both black. And then there are, this is going to be frustrating. Let me see what I can do. Sorry, guys. 13 clubs and 13 spades. And those are both black. And then for red, there is 13 hearts and then 13 diamonds. So a lot of just remembering 52 and then split in half, split in half, split in half. And then completely separate from that, there is 4 of each like number. So like there's 4 aces, there's 4 twos, there's 4 threes, there's 4 jacks, there's 4 queens, there's 4 kings, and so on, because there's like 1 in each suit, right? There's an ace of clubs, an ace of spades, an ace of hearts, an ace of diamonds, and so on. And then specifically for the question that you asked, face cards. So face, nope. Oh, I wish I remembered how to fix this. Oh, wow. Oops, I went too far.
How did I die?
Okay, I'm going to switch to typing. For face cards, there are, okay, so face cards are Jack, Queen, King, and there's one of each in each suit, which means that there's a total of 12 face cards because there's 4 Jacks, 4 Queens, and 4 Kings. And so that's kind of all the generic information that you need to know about a deck of cards. And then specific to the question that you're asking about, so it wants to know the probability that both cards pulled are face cards. And then usually on card problems, we do without replacement. So I'm going to assume that this is without replacement. And if it's not without replacement, then we'll change the second fraction. And so I just said that there are 12 face cards in a deck of cards. So there's 12 total face cards out of the 52 total in the deck. And then without replacement means that like when I take out a face card, it won't be in the deck anymore. So when I go back for my second card, now there's only going to be 11 face cards in the deck. And then there's now also only going to be 51 cards total in the deck because I took one of them out. And then from there, we multiply. These problems you can either simplify before or after, but you always do want to simplify at some point in time. I like to simplify at the end, so I'm going to multiply 12 times 11, which is 132, and then 52 times 51. I should probably go get my actual calculator. 2652. This is not going to work. And then you can simplify this. Let me go grab my actual calculator because that's going to be easier for me to simplify on. So give me 2 seconds to do that. So if you're using a TI-30X IIS, if you're using that type of calculator, there's a button on there. I like to call it the ABC button. It says A, and then there's like B over C, and that's the fraction button. And for these types of problems, you could type in the question with the fraction button, and it'll automatically simplify for you. So if I type in 132 ABC 2652 and then hit equals, it'll simplify it for me. And it turns out that simplifies into 11 over 221. And so that would be your final answer, 11 over 221. Okay, that's assuming that that one was without replacement. If it was with replacement, you would basically just do the same fraction twice. You would do 12 over 52. And then you would multiply that by 12 over 52 again. I can't do this. I need to, I wish this pen was working. I know there's a setting I can change, I just don't remember what it is. This all looks very incoherent. I am really sorry, guys. I'm going to see if I can... There's something weird that I needed to do to fix it, and I don't remember what it is. Okay, we're going to work with what we have. Okay, 12 over 52 times 12 over 52. So that would be with replacement, because that just means that when you take the card out, you put it back in. So I hope that helped. I'm sorry we're having some technical difficulties tonight. We work with what we have. All right, let's try that next problem. Oh my goodness, where did that go? Oops. Sorry, apparently it decided to close out my window. Okay, let's try another problem. Can you explain using number 8 on the quiz? Yes. Why we just multiply to get the answer instead of using combinations or permutations. Okay, so number 8 on the quiz says Jeremy wants to order a pizza and a beverage for lunch. He has a choice of 11 pizzas and 6 beverages. And how many possible lunches can we make? So just a refresher for those of you, just like what like the NCR and NPR, like what does that actually mean? So NCR means I have N things and I'm choosing R of them. And then NPR also means the same thing. I have N things and I'm choosing R of them. And so when you have NCR and NPR, that means you have like, I have a whole bunch of stuff, and from that stuff, I'm going to pick some of them and only use some of them. So when you're reading question 8, because I had a lot of students who tried to use, I think they tried to use NCR. And so what they wrote down on their papers and what they calculated, they did 11C6. And so you have to remember that what that means is I have 11 things and I'm going to use 6 of them. Now, if we think of that in the context of the problem, that doesn't make any sense. I'm not choosing 6 things. I'm choosing 2 things. I'm choosing, and this is why we're doing fundamental counting principle instead. I am choosing pizza, and that's supposed to be a P. And I'm choosing a beverage. That's it. I'm choosing one of each. I'm choosing a pizza. I'm choosing a beverage. Also, when you do NCR and NPR, it's more like I have a big stack of books, and I'm going to take some books out of the stack, right? So like 11C6 would be, I have 11 books sitting on the floor, and I'm going to pick up 6 of them. So when you wrote that about this problem, what you're saying is, because you kind of mix and matched the 2 different things that you were taking. You had pizzas and beverages. But when you mix the numbers together in a C problem, you said, I have 11 pizzas, and I'm going to pick 6 beverages. And so again, it really doesn't make sense when you try to say out loud what you wrote as the combination, or if you did permutation. I mean, it's the same thing. I have 11 pizzas, and I'm going to pick 6 beverages. It doesn't make sense when you try to say it out loud. So remember that the notation, the C notation and the P notation, it means I have this stack of things and I'm going to pick some of them out of the stack. And so pizzas and drinks, that doesn't make any sense. Also, since it was 2 different things, pizzas and drinks, again, you don't want to use a combination or permutation. You do want to use like 2 separate lines, one representing pizza and one representing drinks. Since you're only going to have 1 slice of pizza, you just draw 1 line about the slice of pizza that you're going to have, and you would write the total options that you have available to you, which is 11, on that line. And since you're only going to drink 1 drink, again, you draw 1 line about the beverages, and you write how many options total you have to choose from. You have 6 drinks to choose from. And then you would multiply them together because you are having pizza and a drink. And so I hope, my students for sure did, and maybe your teacher told you as well. When you see and, that means multiply. And then when you see or, that means add. And I know that's a little bit confusing because and add both start with A, so we want to do and as adding, but that's just not how it works. So that's why that one was not a combination or a permutation. And I hope that helped, and I hope it did not confuse you more. All right, so next, staying with the quiz, we're going to do 24 and 25. All right, so 24 and 25 are geometric probability. And in geometric probability, the most important thing to remember is that you have to calculate the area of the picture. So you never want to just take it, the numbers that were given to you, so you don't want to use like the 3 and the 9. What you want to do is you want to calculate area. And sometimes what I'll do on these problems is before I even start trying to figure out the problem, I'll just find the area of everything that I see in the picture. So the area of the small square is 3 times 3, or 9. And then the area of the big square is 9 times 9, or 81. And so that's kind of really what you need to be able to do this problem, is you need the area of both the shapes. Question 24 wants to know the probability of landing in the shaded region. So now the shaded region, and usually when we do shaded regions, what you're going to do is you're going to do the whole shape minus the white shape. Because you've got to kind of like punch out the white shape so that you're left with only the shaded part. And so in this problem, what that's going to have us do is it's going to have us do 81, because that's the whole shape, minus the small square, which is the 9. And if we do the whole shape minus the white box, then we'll be left with the shaded area. So the area of the shaded region is 72. And then you always want to do probability over the area of the whole shape, which in this problem was the big square. So you're going to do 72 over 81. And then that can simplify. Those are both divisible by 9. And so you will get 8 over 9. So that was the answer to number 24. For 25, there's 2 different ways that you can do it. So 25 says, what's the probability of landing in the white region? So then you just put the white area, which was the small square, the 9, over the total area, which was the 81. And that simplifies to 1 over 9. Or the other way you could think about it is the white square and the shaded part together makes up the whole picture. And so if the shaded part was 8/9, then the other part has to be 1/9 to make one whole picture, because 1/9 plus 8/9 equals 1. So that was 2 different ways that you could have figured out number 25. Number 25, again, the final answer is 1 over 9. You're welcome. Okay, and then it looks like our next question is on number 11 on the test review. Let me find my test review. Oh, that's a pretty straightforward question. Combinations, it's a little bit, let's talk about permutations first. So permutation is when order matters. Specific words that you're looking for are arrange, line up. You could give people titles like president, vice president, secretary. You could give people rankings, first, second, third. Those would be all the times that you would do a permutation. So those are kind of the key words that you're thinking of for permutation. For a combination, that's when order doesn't matter, or when you just want a group of stuff, just kind of like all piled together. You don't really care what anything, like what order things are in. You're just kind of like throwing a bunch of stuff together. And on a combination, unfortunately, there's not key words like a permutation has. You just have to think to yourself, like, does the order matter? Do I care what order this happens in? Some things that we commonly ask about are like a cabinet of people. So like an ASB cabinet, as opposed to an ASB president, vice president, secretary. Like if you're just making a cabinet, it's just like a group of people. Sometimes we'll say choose, but you know what? That one's kind of tricky because sometimes we say choose on permutation also. So choose does not automatically make it a combination. So that can be a little bit tricky. And what else? I feel like there was another one that I was going to say. Honestly, if it's not a permutation, it's a combination. And so, I mean, that's kind of the best thing that I can do for you is if you don't see any words that specifically make it a permutation, then it's probably a combination. Yeah, you got to think about again if the order matters. Oh, another one that was on a different homework, one of our like earlier homeworks, it was like, what did it say? They're picking like raffle prizes, but everybody gets the same prize. That's a combination because that means that it doesn't matter if you got picked first or fifth, you're all getting $50, whatever the prize may be, right? So as long as you're all getting the same prize, that's a combination. If the first person gets a prize of $50 and then the second person gets a prize of $40 and then the next person gets a prize of $30 and so on and so forth, that would be a permutation because then you care if you're picked first because you win more money if you're picked first. So then the order that you're picked in does matter. So again, it's all about, do I care what order things are in, or it's just all thrown together and it doesn't really matter. So I hope that helped. We did talk earlier about fundamental counting principle, the ones where you draw the lines, because those are all kind of mixed in together, right? Fundamental counting principle. And that's the one where you draw the lines. Like I'm going to pick a pizza, a beverage. So a lot of times on those, it'll be more than one item, like the pizza and the beverage one that we did earlier, or it's going to be like pants and a shirt and socks and shoes. So you have like a whole bunch of different things that you're choosing from. If you're picking just a whole bunch of pants, then that could be a permutation or a combination because you're only picking pants. But if you're picking a whole outfit with many different things, then that's fundamental counting principle. Fundamental counting principle is also interchangeable with a permutation. So you have to be a little bit careful with that because those two can go hand in hand. Every permutation can be solved using fundamental counting principle as well. So it's just a different way to do it. And then fundamental counting principle, you're also looking for those keywords and or. And so those three concepts were all taught in the same section. And so those three concepts are going to be very close to each other and kind of mixed up together on your test. All right, 7 on the quiz is next in our list. This is over here. 7 is the Venn diagram. Oh, that's going to be... Can I draw circles? Ooh, a circle, yay. Okay, awesome. Circle, circle, square. All right, score. That was great. Oh, text size needs to go down a lot. Okay, so on the Venn diagram, a couple things that you need to do. You need to make sure that you're labeling your circles. So in this particular problem, we have people taking French and we have people taking history. So you want to make sure that you've labeled the boxes so that we know which circle is representing which thing. And then in reality, the only number that you can actually write in the Venn diagram that also shows up in the problem are the people that are studying both, those people that are in the overlap. And so the only number that I'm going to full on just pull out of the question and put in the Venn diagram is the 15, because those are the people who are taking both French and history. And so I can put that right in the middle. Every other number that's in the actual problem, I'm not going to use as it is. So what you need to do next is you need to take away the people that are taking both from the people who are taking it individually. For instance, it says that there's 105 people studying French. I'm going to do 105 minus the 15 that are already counted in the people who are studying French and history. And so instead of writing 105 in my Venn diagram, I'm going to write 90. And so you want like the two numbers together, the 90 and the 15 together, to equal the 105 that was told to you in the problem. Same thing with history. In the problem, it says that 82 are studying history, but I need to take out the 15 who I've already have in my Venn diagram. So I'm actually only going to write 67 here. I'm not writing on the screen the math that I'm doing, but I'm saying it out loud. I hope that's enough. Let me know if that's not. If you want to see, like, I can actually write out the equations that I'm using, if that helps. For the last thing, we need to have a number in the square. The number in the square is going to represent the people who are not taking French and are also not taking history. To get that number, we're going to add together the French, the history, and the together people. So I'm going to add 90 plus 15 plus 67. And that gave me 172. So right now my total is 172 people. But if I read the problem, it says there's actually 200 people. So finally, I'm going to do 200 minus 172, and that gives me 28. And 28 is what goes out here. And these are the students that are not studying French and are also not studying history. And so that's how you fill out the Venn diagram. And I do believe we're going to have points for filling out the Venn diagram correctly. So don't forget to label your circles and then make sure that you only have 4 numbers in your Venn diagram. All right, and then we asked you some questions. So question A says, how many students study history but not French? And so they are looking for these people. So the answer to letter A is 67. There's 67 people studying history but not French. And then letter B says, how many students are not taking history or French? And that's this last number that we got out here. 28 people are not taking either of them. So that's our B. And then finally, letter C says, what is the probability that a student chosen at random is studying French but not history? Since letter C says probability, they want a fraction. Anytime we're asking for probability, we always want a fraction. And then they want the French but not history people, which is 90. And on the bottom of the fraction, I should put the total amount of people, which was 200 from the original. You had to read that in the original question. And then I can simplify that. I can divide by 10. And so the final answer for part C is 9/20. So that was part C. And that was number 7 on the quiz. You're welcome. All right, we're going to switch back to the test review for, it looks like the next 4 problems will be off of the test review. We're going to start with numbers 31 and 32 on the test review. Oh, let's start by saying that number 31 has a typo in it. Number 31 is supposed to say, let me bump this up again. I'll retype it up here. Given that M and N are independent events, fine. And then it's supposed to say P of M and N, not Q and R. That's a typo. If P of N is 2/5 and P of M is 1/3. So this is what that problem was supposed to say. That it did have a slight typo with the letters in the first parentheses. Those are supposed to be M and N. And then on these problems, honestly, they should be pretty, they're a lot easier than they seem. the wording and the it looks really complex. In reality, what you're going to do is you're going to look in this parentheses, and I see the word and means multiply. So that's all I have to do. I'm just going to do 2 over 5 times 1 over 3. So, and just like we talked on the fundamental counting principle, like question 8 on the front of the quiz, and means multiply. And that gives me 2 over 15. And that's my answer. So lots and lots of words that in reality are just telling you multiply these two numbers together. And then the next one, that one does not have any typos. That one is fine. Oh, also, like, try to stay consistent. So if the original problem is written as fractions, you probably want to write your answer as fractions as well. The next problem is written as decimals. So I am going to, oops. I'm going to write my answer as decimals. So the next one says, given that R and Q are mutually exclusive events, find P of R or Q if P of R is 0.5 and P of Q is 0.1. All right. So that's what the problem says. And then, again, lots of words, lots of fancy looking stuff, all just trying to ultimately lead you to here, where I see the word or, and or means add. So this was a very, very, very fancy way of saying, let's add 0.5 plus 0.1. And again, since they were originally given to us as decimals, I'm going to keep them as decimals for my final answer. So 0.6 is my final answer. You're welcome. I'm trying to figure out what you mean, because I don't know that I have that review, the dice review that you're talking about. Find the probability that the first roll is a total of at least 10 and the second roll is a total of at least 11. Are you rolling 2 dice? Because I don't feel like I have the paper that has that problem on it. And so I just want to make sure that I fully understand your question. And then while you're clarifying that for me, and I appreciate that, I'm going to do 25 and 26 from the review that I gave my students. And then we can definitely take a look at your problem. Okay. 25 and 26. So these are card problems. I will also say, and it doesn't say on the review, but I'm pretty sure we will make sure that we typed it on the test, that on the card problems, it's always going to be without replacement, which means that when you take a card out, you're not going to put it back in. That's just kind of how card problems work in general. In the community at large, you don't usually put the cards back in. You usually keep them out. And so that's what we're going to assume that these problems are. It doesn't specifically say, but we probably should have said that. So the first question, which was number 25, says the probability of pulling 2 black cards or 2 clubs. And so in this problem, it's really important that you fully understand the kind of tree diagram that I drew on the very first slide. We can actually go back to it if you need to, explaining the different cards. And very specifically, it's really important that you understand that 2 black cards or 2 clubs. All clubs are black cards. If I were to draw a Venn diagram about the black cards and clubs would be completely inside of the black card circle. It's a completely encompassing Venn diagram. And so that's really important for you to understand, because what that means is, let's see, where did I leave off? What that means is when I'm calculating the probability of finding 2 black cards, I'm also completely calculating the probability of finding 2 clubs. And so since clubs are completely contained within the set of black cards, we actually don't even need to calculate the probability of 2 clubs. It's already going to be calculated when I calculate the black cards. And so I'm actually just going to calculate the probability of getting 2 black cards. And so if you remember back to our little tree diagram we had earlier, black cards are 26. And then if we are not doing, or if we are doing without replacement, then it's 25 and 51. And like I said, I like to multiply first and simplify later. So I'm going to do 26 times 25, which is 650. And then I'm going to do 52 times 51, which is the same thing it was earlier today, 2652. And I'm going to utilize that ABC button again on my calculator. So that's A and then B over C. So I'm going to type in 650, and then I'm going to hit the ABC button. When you hit the ABC button, it puts like a little backwards L, and that's supposed to mean a fraction bar. 2652, and my calculator magically simplifies this into 25 over 102. And so again, since clubs are completely contained within black cards, I'm going to actually just kind of ignore that part of the problem. I don't need to do anything with it. Okay, and then the one immediately after that, number 26. Number 26 uses a different notation, and it's a notation that we haven't really used with cards before, but we've used it with like the tree diagrams and with the table problems. And that one says, find the probability that you have a heart, and then it has a straight up and down line, and then it says the word red, and then the way you read that is find the probability of choosing a heart given that you definitely drew a red card. And what that does is it changes what you are choosing out of. So like I'm now no longer choosing out of the entire deck of cards. I'm now very specifically saying I definitely have a red card. So my total is not going to be the total amount of cards in the deck. Because I definitely know I have a red card. My total is now 26 because there are 26 red cards in the deck. So whatever word comes after the bar, that's what you're going to put for your total on the bottom. And then of the red cards, there are 13 hearts. So I'm going to put 13 on top. And so that simplifies to 1/2. So if I pulled a red card, if I for sure pulled a red card, I have a 1 in 2 chance that it is a heart. And then the other option would be if it's a diamond. All right. So that was 25 and 26 from the review. Let's take a look at this one, this dice problem that was wonderfully typed out for us so we can all see what it says. So this one says we have, so it's really important on this one, we're rolling 2 dice. Which kind of changes things a little bit for us. So 2 dice, and it's important to know when you're rolling 2 dice that there are 6 sides on one and 6 sides on the other, which means that there are 36 different ways to roll 2 dice. So that's going to be our total number is 36 for the bottom of our fractions, right? Because we have to do probability, so we have to have a bottom number on our fractions. And then it says, well, what is the probability that the first roll is a total of at least 10? So now what we need to do is we need to think of all of the numbers on the dice that can add up to 10. Because that'll tell us like how many different ways we can get a number that adds up to 10. So for instance, we could have 4 plus 6, that's 10. We could also have 6 plus 4, that would also be 10. We could have 5 plus 5, and that's about it. That's it. So these are all the different ways that we can add up to 10. It does say that it wants a total of at least 10, which means it would also accept a total of 11. And 11 would be 5 plus 6 or 6 plus 5. And that also means that it would be okay for us to get a total of 12, which is the highest total that you can get given 2 dice. So I'm also going to include that. So if we're looking strictly at the first roll, and we want a total of at least 10, I count 1, 2, 3, 4, 5, 6 different ways out of the 36 total different ways that I could get a total of at least 10. So the probability for my first roll is a 6 over 36. Then I'm going to roll again. And on the dice problems, it's not like the card problems where like you take away 1 every time that you roll the dice. Every time you roll the dice, there's always going to be 6 sides on the dice. So you never have to do that subtracting thing like we did with the card problems. For my second roll, I want the total to be at least 11. So now I'm going to count the amount of ways I can roll an 11 or a 12. And that's 3 ways out of, again, the 36 total different ways that I can roll 2 dice. And then we multiply. So 6 times 3 is 18. I don't know what 36 times 36 is, but my calculator does. It is 1296. And then we're going to hit that ABC button, 18 ABC, 1296. And I get a final answer of 1 out of 72. Okay, and so that's how you would do that dice problem. Again, since we're rolling 2 dice at a time, it's a little bit different than our other dice problems that we've been doing, where we're only rolling 1 dice at a time. When you're only rolling 1 dice at a time, there's the denominator is always just going to be 6 because there are 6 sides to the dice. I don't have them. They're on top of the printer.
How are you talking?
I have a mic on my laptop. Sorry, guys. Carlo, on the 11-4 homework, is it the table homework or the tree homework? Because there were 2 different homeworks. Table, okay. Okay, and I just want to clarify. Wait. Never mind. 5 and 6. 5 and 6. Got it. Okay. I was thinking it was 4 and 5, and then I was confused because 4 was from one table and 5 was from a different table. So first of all, on these problems, and unfortunately I'm not going to type out the whole table for you, but on these table problems, the very first thing you should do is get totals all around the whole table. So you should add together all of the entire top row, 39, 48, 85, 62, 71, and 29. You should add together the entire second row, which is 67, 58, 76, 54, 68, 39. And then after you add together all of the rows, then you're going to go and add all the columns. So basically, you're just trying to get a total for every row and every column. And then you also want a total for the entire table. So that needs to be kind of figured out before you even read the questions. Now, 5 and 6 are very similar problems, but the order has been switched. So on question 5, it says the probability of sports. I'll write it out. This is how you should say it in your head so that you really kind of like understand what it's asking. The probability of someone, I guess, doing sports, given that they are definitely female. Okay, that's what question 5 is asking. And then question 6 kind of switches it. So question 6 says the probability of someone being female given that they definitely enjoy doing sports. And so again, they both say sports, they both say female, but because they're in different orders, that changes the numbers that we're going to use. It actually only changes the bottom number of the fraction. The top number for the fraction is going to stay the same. So if you remember on the card problem that we did a little bit earlier, we said that this line is almost like a fraction bar. And so the word that comes after that is what should go on the bottom of the fraction. This is not working well. I apologize, guys. That's supposed to say the word bottom. And so what you want to do, again, you should have added together all of your... I wish, well... If I had the table on the screen in front of you, what I would do is I would cover up the bottom row where it says male so that you can only see the top row where it says female, because that's the row that we're going to focus on. We're going to focus on the row that says female. And because I've done my pre-work, I have already added together all of the female numbers. Again, that's 39 plus 48 plus 85 plus 62 plus 71 plus 29. And I've discovered that the total amount of female in this chart is, nope, 334. And so I'm going to put the total amount of females on the bottom of my fraction, 334. And then on the top of my fraction, I put down the sports people who are also female. So that would be female sports is 39. And so that's what this fraction looks like. The probability that someone enjoys sports given that they are female. For the second fraction, again, a little bit different. This one says the probability that someone is female given that they definitely enjoy sports. So that means that our total sport number is going to go on the bottom of the fraction. So we have to put a different number on the bottom of the fraction. So again, if I had this sitting in front of you and we were staring at it, I would cover up everything to the right of the word sports, so that all you could see was the 39 and the 67. And hopefully you could also see that you added together 39 and 67 and got that there was 106 people total who enjoy sports. And then after that, you want to focus on just the females who enjoy sports, which will be the same number that we used for the top one. It'll be that 39. There were 39 people who were female and enjoyed sports. And then if I type those into my calculator, I will discover that that does not simplify. So those would be my final answer. I think the biggest thing on these problems is just making sure that you have the correct total on the bottom and that you did add together to get those totals, because those are not given to you in the table. A pair of dice are tossed. What is the probability that the sum on the dice is 8, given that the sum is more than 6? Yikes, that is a lot of work there, Jim. Okay, so I'm going to start with, given that the sum is more than 6, that means I have to think of all the different ways that I can add 2 dice together to get 6 or higher. Let's start with all the different ways to get 6. So that would be 1 plus 5 and 5 plus 1. That would be 2 plus 4 and 4 plus 2. Notice that I'm going commutative property, switching them up. 3 plus 3, and I can't switch that one up because that would still be 3 plus 3, and I think that's it. So in total, to equal 6, there are 1, 2, 3, 4, 5 different ways to get a total of 6. Now it says it wants, given that the sum is, oh shoot, yeah, I should have read that a little bit more closely. Given that the sum is more than 6 means we don't want it to be a sum of 6, so I'm going to erase all of that work that I just did because it does not apply. I actually want it to be a sum of 7 or more, so let's figure out that instead. So a sum of 7 is 1 and 6, and then also 6 and 1. We have 2 and 5, and also 5 and 2. We have 3 and 4, and also 4 and 3. 7, by the way, is the most common number that you can add up with 2 dice at 1, 2, 3, 4, 5, 6 different ways to get a sum of 7. Next, we need so it says a sum of more than 6, so we need all the numbers bigger than 6. So 7, next we'll need to do 8, which is 2 plus 6 and 6 plus 2. It is 3 plus 5 and 5 plus 3, and it is 4 plus 4, giving us a total of 1, 2, 3, 4, 5 different ways to add up to 8. Next, we'll do 9. which is 3 plus 6 and 6 plus 3. Oops, not hitting that shift button right. 3 plus 6, 6 plus 3, 4 plus 5, and 5 plus 4, giving us a total of 4 different ways to get the number 9. Next we have 10. I know this is a lot of writing, but this is just kind of what you got to do unless you have a dice chart. You got to figure this all out. So what are we at? 10. So that's 6 plus 4, 4 plus 6, and 5 plus 5. I hope you're seeing a pattern here. It is diminishing by 1 each time. So this one only had 3. Given that pattern, I'm going to guess the 11 only has 2. I'm trying to keep my notation accurate, and then that would mean also given that pattern that 12 only has 1. Okay, so in summary and in total, given that when I rolled my 2 dice, I definitely got a sum that's bigger than 6, there are, calculator, 6 plus 5 plus 4 plus 3 plus 2 plus 1, 21 different ways that my 2 dice could add up to a number that is more than 6. So again, I just added 6 plus 5 plus 4 plus 3 plus 2 plus 1. Then it says, actually prior to that, it says, what is the probability? I'm going to be honest, Jim, I don't think we're going to roll 2 dice on the test. I think we're only going to roll 1 dice at a time. So I don't think you'll need to do a problem this extensive on the test. I totally agree. But let's go ahead and finish up this problem because I'm assuming it came from somewhere. So let's make sure that you understand what the final answer is. So it says, what is the probability that the sum on the 2 dice is 8? And so we discovered in making this chart that there are 5 different ways to make 8s. And so the probability is 5 over 21. All right, next I'm seeing 28 through 30 on the test review. All right, so these are those Venn diagram problems again. And you definitely want to, we'll have the Venn diagram actually already drawn out for you on the test. You just need to fill it in with the numbers. So, and you'll need to label it as well because we will not be labeling it for you. So you will need to write in the words on the Venn diagram as well. All right, so in this one, we have baseball and track. I'm going to label this one baseball and this one track. And then again, the only number that you straight up take out of the math problem is the one that says that they are in both baseball and track. And those are the 8 people, and those 8 people go right here in the middle. The line means, Hayden, the line means the word given. So what is the probability that you drew a red card given that you definitely pulled a heart out of the deck of cards? That's what that means. All right, and we did a Venn diagram problem earlier today. We said that you're going to take the baseball people, which is 19, and you're going to subtract out the people that are in both 8. And so that means that in the baseball circle, I should really only write 11 because the 11 plus the 8 together should make the 19 from the problem. And then I'm going to do the same thing for track. I'm going to do the 13 who are in track, and I'm going to minus out the 8 who are in both so that I discover that there are 5 people who are in only track. 13 people total in track. 8 are in both, 5 are in only track. And then the last calculation you need to do to fill in your Venn diagram is you need to add those 3 numbers together, 11 plus 8 plus 5, which is 24. And you will subtract that from the total amount of people, total amount of students. So there were 31 students minus the 24 currently contained in my circles gives me 7 students who are in neither baseball nor track, who are not in either of those. So that's how you do the Venn diagram. I'm just making sure 28 through 30. All right. So number 29 says, find the probability that a student is in track and baseball. That would be the people right in the center of the Venn diagram, those 8 people, and that was out of the 31 students total. So that is the answer for 29. And then Number 30 says, find the probability that someone is not in track. The people who are not in track are the 11 people who are only in baseball, and also these 7 people who are not in either of them. So that makes for a total of 18 people who are not in track out of the 31 people total students. So that would be the answer to number 30, is 18 over 31. All right. 36 and 37 on the test review. And so I'm going to answer Adam's question and Ellie's question, and then we're going to be at our time, I believe, because we only have about 5 minutes left. And so hopefully I answered all of your questions. If not, I will. I did check with the person who's usually in the media center, Griffin Lab, room 750. And even though tomorrow is a minimum day, they did say that they would go to the media center, room 750, for tutoring, since they know that we have a test on Thursday. So there will be another opportunity for tutoring tomorrow after school if you want to stick around and get a little extra help. And then obviously you still have one more day of class, right? We have tomorrow is a class day. All right, 36 and 37. Before we can do 36 and 37, we have to make the tree diagram because that's how this works. And so on a tree diagram, you will have a set of 2 branches, and then off of the end of each of those branches is a set of 2 more branches, like so. You will need to label with bare minimum, like letters, possibly with words. And so what you want to do is you want to find, there's going to be 2 sets of things that are happening. And in each set of things that are happening, there's like a thing happens, and then there's the opposite, like the thing doesn't happen. The thing happens, the thing doesn't happen. So if we're reading through this question, it says, a study of Algebra 2 students showed that 70% of the students do the homework on time. Out of the 70% of students that do their homework on time, 20% check their answers. Out of the students that do not do their homework on time, 10% check their answers. So what I'm seeing is I have students doing their homework on time and students doing their homework late. I have students checking their answers, and I have students not checking their answers. Now, checking their answers ended up happening twice, once with doing their homework on time and once with not doing their homework on time. So I'm going to say that on time, oh, that sucks. Hold on. On time is going to be one of our initial branches, and then late would be the opposite of on time. And then the people who did it on time, some of them check their answers, and the other ones don't check their answers. And same thing with the people who do their homework late. Some of them check their answers, and some of them don't check their answers. You could also, again, you don't have to use full-on words if you don't want to. Just make sure that your letters will make sense to the person reading it. Because if we don't understand what your letters mean, then we don't know if you're doing it correctly. Now we need to put numbers on all of the branches. So it says, a study of Algebra 2 students showed that 70% of students do their homework on time. So that would be this branch over here. I am going to write it as a decimal 0.7. And every pair of branches has to add up to 100%. Or the whole number 1. And so if 70% do their homework on time, then that would mean that 30% or 0.3 do their homework late. So you always want each pair of branches to add up to 100%. My next sentence says, out of the 70% of students that do their homework on time, 20 check their answers. So the on-time checking people is 20% or 0.2. Which means the on-time not checking people is 80%, 0.8, because 20 plus 80 is 100. Then it says, out of the students that do not do their homework on time, so those would be my late students, 10% check their answers. So late students that check their answers is 0.1 or 10%. And then that would mean that the other 90% of them do not check their answers, so 0.9. So again, you want to make sure that each branch adds up to 100. And that's how you make the tree chart. And then from there, you can answer the questions. So our first question says, what is the probability that students check their homework answers? Now, that one's a little bit tricky because there are two different pathways that we can go through to see if people check their answers. So our first pathway is a student did their homework on time and they checked their answer. And then our second pathway is a student did their homework late and they checked their answer. And so since there's two different pathways, we're going to have to do a little bit of work. Also, this is the type of work that, your teacher, me and the other teachers, this is the type of work we want to see on your test. So please don't just write down answers. Please make sure to write down on your paper, what is the math that you're typing into your calculator that gave you that answer so that we know where your answers came from. All right, so I have on time and check, or I have late and check. Now, I said that in a very specific way because we're going back to what we talked about kind of at the beginning of the session, where and means multiply and or means add. So I'm going to take my decimals that are along my pathways, and every time I see an and, I'll put a multiplication sign, and then anytime I see an or, I'll put an addition sign. So here I have on time is 0.7, and then and means multiply, and then my on time checking people is 0.2. So I'm going to do 0.7 times 0.2. Then I see the word or, so I'm going to add, and then I'm going to do my late people, which is 0.3, and then I see the word and, so I'm going to multiply, and then my late checking people is 0.1. So that's what I'm going to type into my calculator. And again, this is the type of work that that your teachers want to see on your paper. So 0.7 times 0.2, if you want to do it even more work, 0.7 times 0.2 is 0.14. And then 0.3 times 0.1 is 0.03. And 0.14 plus 0.03 is 0.17. Or if we're going to stay consistent, because the original problem did have everything written as percentages, so we might want to change that back to a percentage, and that would be 17%. And so 17% is the answer to number 36. All right, now number 37 is very, very differently written and a completely different way of doing the problem. So number 37, I'm going to see if I can squeeze that in at the top so we don't have to change the slide. The probability that students check their homework if done on time. So this one is kind of like those given problems that we were doing earlier today, where it's like we definitely, if done on time, means they definitely did their homework on time. So no doubt about it, this part definitely happened. And so it wants to know what's just the probability that they check their homework. So this one is just straight up, you're just going to take that 0.20. And so the answer to that one is just 20%. Now, I will warn you, on your test, it's probably going to be more like problem 36 than like number 37. So, and we had some problems like that on our quiz as well. It was question 23. The test is going to be worded more like question 23 from the quiz rather than questions 37 through 39 on your homework. So don't let the homework deceive you, because 37 through 39 are actually just like, tell me number off the table, off the tree chart. It's going to be more like number 36, where you have to do a little bit of multiplying. Okay, so one more person had a question, and so I know we're a little bit over time. Thank you for staying with us. I am going to answer that very last question that was typed into the chat box. Again, you still have I think it's like 40-minute class period. It's a minimum day, but I think we still have 40 minutes together. So you do have 40-minute class periods tomorrow with your teachers where you can ask them help. Actually, I'm going to have a tutoring session in my room in the morning. So if you get to school early and you just need somewhere to go, feel free to stop by my room in the morning. My room is room 350. And I will have tutoring in my classroom in the morning. And then there's also tutoring in room 750 after school, immediately after school. So as soon as 6th period is over, you can go to the media center and get help there. All right, 2C and 2D. Yikes. Okay, yeah, let's do it. These are going to be a little intense. So we might run really late. Okay, so 2C says find the probability, and we're doing, these are card problems. Find the probability that you get 2 red cards or 2 jacks. All right, so this one's going to get pretty intense. So let's start with the probability that we get 2 red cards. So there are 26 red cards out of 52 cards total. And then for my second card, there will be 25 red cards out of 51 cards total. Okay, so that's my probability that I get 2 reds. And let's go ahead and just figure that out. 26 times 25. I know we've already done this today because we keep using the same, you guys on the card problems, you're going to use the same numbers like over and over and over again. Okay, Mary. Don't forget too that if you can't stay for this whole session, it is being recorded, so you could always watch it tomorrow night. Anything that you missed, if you came late, you could watch it tomorrow night. You can watch from the beginning. You can watch from wherever you left off, because everything's being recorded. All right, and then it says or, and or in this scenario means and. What if we pull 2 jacks? So we need to know that there are 4 jacks in a, oh, that I did not mean to do that. There are 4 jacks in a deck of cards because there's one of each suit. So I have 4 jacks out of the 52 cards. And then if I take one out, now I will only have 3 jacks out of the 52 cards. And so there's my second probability, which is 12 out of the 2652. Okay, so that's red cards and jacks. Now this problem gets a little bit complicated because some of my jacks are red. The jack of hearts and the jack of diamonds are red jacks. So we have this overlap. We have this overlap where when I was calculating the probability of pulling out 2 red cards, at some point in time, I calculated the probability of pulling out a red jack and another red jack. And also, when I was calculating the probability of pulling out a jack, I calculated the probability of a jack and a second red jack. And so the red jacks accidentally, they got double counted. They got counted twice. They got counted in pulling out the red cards, and they got counted in pulling out the jacks. And so we need to get rid of that overlap where we accidentally counted the same card twice. And so we do that by subtracting off the probability of pulling out a red jack. And there are 2 red jacks because there's a jack of hearts and a jack of diamonds. And then once I pull out one of those red hearts, there will only be 1 red heart left over. So this problem, because there's a overlap, also needs a little teeny tiny bit of subtracting in it. Okay, so I had calculated my red cards, I calculated my jacks, and then I need to subtract out the red jacks because of that overlap. And so now I'm going to do 650 plus 12 minus 2 is 2. And so I've discovered that it is 660 out of 2652. And I'm going to use that ABC button, and I'm going to type out the number 6 twice and not once. And so the final answer to this problem simplifies to 55 over 221. Make sure on your test also that you are always writing your simplified answer. We do want fractions, not decimals, unless the original problem had decimals. So yeah, that was... this is all on the homework 11-3, homework day 2. Okay. Part D, very similar concept of we're going to calculate spades, we're going to calculate face cards, and then we're going to subtract out the face cards that are also spades. Okay, so let's go ahead and do that one. Hopefully we can do it a little bit quicker so we can get you out of here. I know you probably have other things you need and or want to be doing right now. So again, this one says the probability of pulling out 2 spades or 2 face cards. Okay, so just like on the previous problem, we'll calculate each thing individually, and then we'll subtract off the overlap. So spades, there are 13 spades in a deck of cards. And once I take one of them out, there will only be 12 spades in the deck of cards of 51 cards now. So this is spades. Okay, so the probability of pulling out 2 spades is 156 out of, I should know this because I've been multiplying it all night, 2652. Okay, so that was spades. And then next it says or, so that's adding. What's the probability of pulling out 2 face cards? We talked about face cards earlier today. We said that each suit has 3 face cards, a jack, a queen, and a king. And since there are 4 suits, each with 3 cards, that makes a total of 12 face cards in a deck of cards. So I have an option of 12 face cards. When I take one out, I will now only have 11 face cards. And so that gives me a probability of 132 out of 2652. Now this one also has an overlap because there are face cards in the spades deck. There is a king, a queen, and a jack of spades. And so since there's that overlap, since there are cards that are both spades and also face cards, we need to subtract off the overlap. Now, again, as I've shown down here, there are 3 cards that are both spades and face cards out of the 52 in the deck. And then once I take one of them out, there will only be 2 cards that are both spades and face cards. And so I need to subtract off 6 out of 2652. 156 plus 132 minus 6. So that gives me 282 out of that magic number, 2652. And my ABC button tells me 2. The final answer for this problem is 47 over 442. And so that's how you do these problems where the or that they're asking about, where there's an overlap. And we did one like that on the quiz as well earlier, but the overlap is like literally every card. Every card that is a heart is also red. So we didn't do subtracting because we would have just like added and then immediately subtracted it off. So we just kind of ignored it instead. And again, if you have more questions about that, I am available tomorrow morning. I'll be there a little bit after 7. Tomorrow is regular start time, 7:50, and then it's a minimum day. You'll have 40 minutes with your teacher to ask them for help. And then if you have no plans immediately following school, you can go to room 750 for a little extra help from Mrs. Tira. She can help you out. Those of you who are my students, I will see you tomorrow. And the rest of you, good luck on your test. Your test is in 2 days. Feel free to rewatch this video to prepare for your test.